Okay, this lesson is 8 dot expressions and equations, 8th standard. Talks about linear systems. Sometimes you'll hear it referred to as systems of linear equations. So first let's talk about what are linear systems. That's our big A. You might not be able to see that. What are linear systems? Linear system sounds a lot more complicated than what it really is. Linear systems occur when two or more linear equations are on the same graph. Okay? What are we looking for when we graph two linear functions or equations on the same graph to create systems? You are looking for a point of intersection. We know if something intersects, it crosses. So where on this particular Cartesian plane, on this graph, when these linear functions are graphed and they cross, they intersect, at what point do they intersect? The point of intersection is referred to as the solution to the system. So your answer is in the terms of a point. We also call points ordered pairs. So when you answer, you're going to answer in x comma y form or as an ordered pair. So you're trying to figure out, well, Mr. Gray, how do I do it? Okay, you gave me some background information. Now show me what linear systems look like. Okay, so that's my B. Let's go straight into it. B is graphing linear systems. And we are solving linear systems by graphing. There are other ways to do it. You can do it by substitution and elimination. But right now, I'm exposing you how to find the point of intersection by graphing linear systems. So your steps, or your step one, is to graph each equation. Graph each linear equation. Make certain that it's in slope-intercept form. You cannot graph it if it's not in slope-intercept form. And that's y equals mx plus b, for those of you that forgot. That's that form. Step two, identify the point of intersection. And that's where they cross. Identify the point of intersection. Okay? So if I give you two example linear equations, okay? Say I give you y equals 2x plus 1, and I give you y equals negative 3x. Okay? Are those in slope-intercept form? Well, let's see. But I'm going to blow it up on this chart paper. You want to know if those equations are in slope-intercept form. So if I give you y equals mx plus b as the general form, I'm going to place what I have right up under it. Y equals, the first one is 2x plus 1, When I line this up, yes, it is in slope-intercept form. What's my y-intercept? My y-intercept is 1. We know it has to be written as a point, so my y-intercept is 0, 1. And of course my slope is positive 2 over 1. So we'll rise 2 and run 1 to the right since it's positive. Well, let's look at this next linear equation. Start out with my general form. Plug in what you have. Y equals negative 3x. But I don't see a y-intercept. Well, what number represents nothing? 0. So my y-intercept or my b is 0, 0. And my slope, I'm going to drop 3 and run 1 to the right. Or negative 3 over 1. Now I ought to be able to graph those. So watch me graph them. It doesn't matter which one you graph first, just as long as both of them get on there. Is it still recording? Just as long as both of them gets on there. Okay? I'm starting here. Y equals 2x plus 1. I know I start graphing using my y-intercept. Start with my b. This is where you start. We were talking about functions. We would call this the initial value. It all means the same thing. It's your starting point. Okay? You want to start there. Y-intercept is positive 0 on the x, 1 on the y. 0 on the x, go up to 1 on the y. Bleed it. Okay? Stay there. Apply your slope. The top number tells us either to go up or down. Since it's positive, we're going up. How many? 2. Start here, go up 1, 2. Am I done? No. Now I got to run 1 to the right. And I'm going right because it's positive. Stay here. Stay aligned with the 3 on the y, but hover over the 1 on the x because you got to go over 1. Plot your next point. Now repeat, do the process, but do the opposite. Go back to the y-intercept. We went up 2 and right 1. Now go down 2 and left 1. Okay? We got to be able to graph that. Let me get a ruler so it's nice and pretty. Okay? There's that line. Now graph this one. Y equals negative 3x. There's no need to say plus 0. The 0 is just kind of implied. My y-intercept is 0, 0. That's our origin. And I've already got it bled in, so it's kind of hard to write with lime green on top of black. But apply the slope. Go back to the y-intercept for this equation. It's a negative 3 on top, so that's down 3. 1, 2, 3. But my 1 on the bottom is positive, so run once to the right. Go back to the y-intercept and repeat the process. You went down 3 the first time, so go up 3 the second time. I went right 1 the first time, now go left 1, because you're doing the opposite. Connect your dots. Okay, and of course my drawing isn't the best, people. Okay. And in theory, that line is supposed to hit those points. All right, look at it. Where did they intersect? Right here. Naturally, that point is they're supposed to intersect right here at 0, 1. But because my drawing is off, my lines aren't perfect, it doesn't quite make it to 0, 1, but that's where they will intersect. Your answer is where they intersect. According to my graph, it's right here. That's kind of hard to read. We know this point is pretty much near this one. Okay, it's 0, 1. So my answer, I know I have to answer in terms of an ordered pair. So I would say my point of intersection is 0, 1. And I'm finished. That's it. You graph them and express the point of intersection. Your point of intersection is also known as your solution. If I wanted to see if this point was correct, you guys know how to do substitution. Take both of these equations and plug this point in, see if the left side equals the right. And that's our check method.